In this lesson, we're going to build on the work we've already done on bubble sorts, and we're going to start trying to trace changes in variables as we go through. By the end of the lesson, we will have reviewed bubble sorts again. We'll have explained the pseudocode and Python code that actually works for a bubble sort, and we will create a table that traces the variables as the bubble sort works through. So just a quick reminder, bubble sort check 2 elements at a time. So in the first items list, you can see it's checking position 0 and position 1. They start with the first and second elements. They swap the value of those elements if they meet the criteria needed, so ascending or descending. They then move on to the next pair and compare the next two and then the next two. This continues until all pairs have been checked, and they move on to a new pass, which means it starts from the beginning again and carries on going. This continues until all the numbers are in the correct order. Okay, here are 2 algorithms that are doing the same job. The one on the left is written in pseudocode, the one on the right is written in Python. There are some slight differences to the two because of the way that pseudocode and Python work differently with while and for loops. Line 1 sets up an array with some numbers to be sorted. Line 2 sets how many checks are needed to sort the array we've just set up. As we saw last lesson, if there are 5 things in the array, 4 are checked. So the number of checks needed is the length minus 1. For that's it for the pseudocode. For the Python code, because Python counts up to the number before the range you give it, if I put 5 in the for loop, when it asks you to check up to checks needed, it will stop at the one before. So I don't need to take 1 away from it in line 2. Okay, so line 3 sets a count to 0. What that's going to do is count how many times check the list and compare it to how many checks are actually needed. So while the count is less than the needed number of checks, it will run the code from line 4 down. On line 5, it starts a for loop. For the pseudocode, it's counting from a number from 1 to the checks needed. For the Python, it's doing the same thing, but remember, the one on the left will count to 5 minus 1, which is 4, whereas the one on the left will count to 5, but it will do 1 before that, so it will give you the same answer as 4. So lines 5 in both code are doing the same thing because of the way I defined checks needed in line 2. From line 5, it's going to iterate down to line 12 in the pseudocode, and from line 5 down to line 12 in the Python code. This line 6 is setting the count to the count plus 1, which means every time it iterates through the array, it will add 1 to the count value so that it can check to see if it's done the right number of checks. The same will happen in the Python code, except this is done at line 7. The reason I put a print value in for line 6 is I wanted to try and print out the arrays as I go through. Okay, so the if statement on line 7 and line 8 are the statements that are going to check to see if the values are greater than or smaller than each other. So if we look at line 7 in the pseudocode and 8 in the Python, if the item in position number minus 1 is 4 greater than the value in number 2? So item 1. The answer is no, because that item is 7. So it will not swap, and it will iterate back, add 1 to the count, and then try again. Okay. This process will now continue, checking to see if the position 1 is bigger than position 2, and swapping it if it is, and then it will check 2 and 3, and 3 and 4. Remember that all algorithms use arrays that start with position number 0. This works its way through. I will show you how this code works in the next slide. As you can see from the output of this Python code, each line is doing the swaps as it goes down. So the first line is exactly what it looks like before it's done a swap. The second line down is because 4 and 7 didn't swap. It then swaps the 1 and the 7 and the 3, but it doesn't swap the 7 and the 9. As you work your way down the array, you will see that it carries on going even if all the swaps are done, because it's told it has to do the number of swaps needed, so it continues going even though there are no swaps. So if we want to see how the values are changing in this array, what we need to do is work out what is happening at each stage in the code. So the first thing we do is we set the items to the values in the array. So the first lines of code are going to set the array items to 4, 7, 1, 3, 9. The number of checks needed is how long the actual array is. There are 5 values in the array. It sets count to 0. So now we are at line 5 and we are starting the number in range. So it starts with the first number in the range statement, which is 1. The next thing that changes variables is going to be the if statement. But the first way through, the if statement is going to have these numbers in. So the count is going to be 1 because I've added 1 to the count in line 7. Item number minus 1 is going to be 4 because that is looking at position 0. The item number is going to be 7 because that is looking at position 1. These do not swap because the 7 is greater than the 4. So the loop goes back to line 5 and adds 1 to the number. So the value in number is now 2. As we work our way through the for loop again, it's going to add 1 to the previous count. So it was 1, now it is 2. The item that is in items number minus 1 is now the 2 minus 1, so it's in position 1, which is 7. The items in number is going to be in position 2, which is 1. Because the if statement is true, the items number minus 1 position is 7 is greater than the number in the items number 2 position, which is 1. So 7 is going to be copied into the swap variable. So what the algorithm now does is takes what the items from position 2 and puts it into position 1. So the 1 gets moved 1 place to the left. So line 11 now copies what was in the swap variable into the position number 2 for the array. This gives me the new array 4, 1, 7, 3, 9. So we go back to the for loop and we have 1 more added to the number. So the number now becomes 3. So he adds 1 to the count, which makes the count 3. If we now look at number minus 1, which is position 2, we will see that in our new array, we have the value 7. At items position 3, we have the value 3. As the 7 is greater than the 3, we need to swap the 2 over. So the 7 is copied into the swap variable. The 3 is now copied from items position 3 into items position 2. The 7 that was stored in the swap variable is now copied to position 3 in the items. This now leaves me with a new array 4, 1, 3, 7, 9. I'm going to stop here, but we'll continue onwards, carrying on doing it until there are no more swaps to do. So your job, your task for this lesson, is to go through the code given on the right. All I've done is change the values in the array. What I want you to do is create a trace table the same way I did, and you'll need to use the same variables that I used. So work your way through the example I set again, just changing the values that you are given. If you want to try the code, you can click on the link I have put just below. You may need to sign up for an account using your Google login. If you click the Google login key, it will give you the options to do that. The code on the right is I've also given you the output for. The output shows you what the arrays do. Notice that because the array has finished being sorted before the end, this is not the most efficient way to solve the problem. I will show you how to add that in the next session. To complete this lesson, I need you to upload onto ClassChart a copy of your trace table for the new array given. This task is a difficult task, therefore it is the only task for the double lesson. Please try your best. If you get stuck, can you tell me where in the code you are getting confused? Please try not to say line 1. Thank you very much.